In today's lecture, we are going to see about D'Alembert's principle. Let us see about this definition of this D'Alembert's principle. D'Alembert's principle states that the impressed forces acting on the body are in dynamic equilibrium with the inertia forces of the body under motion. This principle has been derived from this Newton's second law of motion. Newton's second law of motion actually states that summation of the forces is equal to mass into acceleration, where mass is expressed in kilogram and acceleration A is expressed in meter per second square. So here let us consider how this D'Alembert's principle has been derived here. This is a simple modification of this Newton's second law of motion. Consider a body of mass m here, and if a force F is applied here, this body it will be moving with an acceleration of A of mass m here. So this mass into acceleration will be the force applied on this body here. This D'Alembert's principle states that there will be an imaginary force applied or exerted on this body which will be acting on the opposite direction of the motion of the body. Suppose this body is moving in the right side direction due to the application of force F here. This ma is the inertia force. This inertia force is said to be the imaginary force which will be acting in the opposite direction of this motion of this body here. So simply we can write this equation as F minus ma equal to 0. Let us see a problem here. So here in this problem, find the tension in the rope. First option, first subdivision. B is acceleration of the body. C1 is distance moved by the body in 3 seconds when it starts from the rest for the figure shown here. Take coefficient of friction mu equal to 0.2 here. So here in this problem it is given with this figure here. So in this figure there are two blocks which are tied together by a cable or a rope here. One is 1200 Newton and another one is 800 Newton. This figure has been given in the problem, and this block is resting on an inclined slope of an angle 20 degree. This 20 degree is called as angle of repose. Let us consider this 800 Newton force is being pulled downward and it is moving downward direction, so that this 1200 Newton is moving upward on this inclined inclined slope here. So here let us consider each body separately and we shall resolve these forces. Consider this 800 Newton block moving downwards. So when it is moving downwards, since this body is not in contact with any of this body or this inclined slope here, there will be only vertical forces. So weight will be acting vertically downwards, and the tension in the rope or cable, it will be acting away from this block here. And as per this D'Alembert's principle, whenever a body is moving downward or moving in a direction, there will be an inertia force ma which will be acting in the opposite direction. So since this body is moving downward, this ma force, that is this inertia force, it will be moving in the opposite direction. So here there is no x direction, that is no horizontal direction of force here. So for summation Fa equal to 0 plus T minus 800 and plus ma equal to 0. Since this m should be always expressed in terms of kilogram, and here in this figure it is given in Newton. So it is, we have to convert this Newton into kilogram. So we know that 1 Newton equal to 9.81, 1 kilogram equal to 9.81 Newton. 1 kilogram equal to 9.81 Newton. So if you convert this mass into acceleration, 800 divided by 9.81 into A minus 800 equal to 0. Let us take this as first equation. So let us move on to the second block, that is 1200 Newton. So considering this block 1200 Newton is moving upward due to the pulling of this 800 Newton weight here. So here the free body diagram of this block has been drawn here. So here 1200 Newton is moving or acting vertically downwards, and this 1200 Newton has been resolved into parallel to this inclined force, and another one is perpendicular to this inclined block here. So here this will be 1200 into sine 20, and this one will be 1200 into cos 20. This vertical force, that is this perpendicular force, will be 1200 into cos 20. And since this block is sliding on this inclined plane, there will be a normal reaction acting vertically upwards, and there will be a friction taking place towards the left side direction as the block is moving upward. And here in this, this block is connected by this rope or the cable. So tension, it will be always acting away from this block here. So tension, it will be acting away from this block here. And since this block is moving upward, there will be an inertia force, that is MA. It will be acting in the opposite direction of the motion of the body. This body, it is moving upward, so it is moving upward, and MA, it will be acting in the opposite direction. So here in this, if we resolve this, summation fx equal to T minus T, it is acting in the right side direction, plus T minus F left side direction, minus 1200 into sine 20 minus MA. So it is also acting in the left side direction, minus MA equal to 0. So F, we can replace it as F equal to mu into n suffix r. We know this, F equal to mu into n suffix r. Mu value, it is given as 0.2. So if you substitute this, we can get an equation T minus 0.2 nr, that is n suffix r, minus 122.32a equal to 410.42. Take this as a second equation. Since in this free body diagram, there are two forces, that is one forces acting along this inclined plane and another one perpendicular to this plane. So far we have resolved parallel to this inclined plane. The next force is perpendicular to this inclined plane. So perpendicular to this inclined plane is plus nr, it is acting upward, plus nr minus 1200 into cos 20 equal to 0. From this we can get nr equal to 1127.63 Newton. So substituting this nr value in this second equation, we are getting T minus 122.32 into A equal to 635.94. So take this as third equation. Solving this first equation and the third equation, we get T equal to 734.38 Newton and acceleration A equal to 0.8 meter per second square. Using these equations of motion, we can find out the distance, how much distance both the blocks have been moved for a time period of 3 seconds. They have given 3 seconds of a time when the block has been moved from the rest. So since the block is moved from the rest, the initial velocity will be u equal to 0. So s equal to ut plus half at square. This is one of the equations of motion. When you substitute this, u equal to 0 as the block moves from rest, and substitute all these values, we get s equal to 3.6 meter. So this is the answer we have got when the block has been moved after 3 seconds.